Hi, welcome to AahGuru question types for JEE and NEET. Each week I take up one question type that comes up in JEE and NEET, basically repeated questions with small variations, and I will focus on how to solve this question type. Today we are going to look at Wheatstone's bridge circuits, basically questions that involve Wheatstone's bridge. And every year in JEE or NEET you will find that you have Wheatstone's bridge questions like this. This appeared in JEE 2024, this question appeared in JEE 2023, this also appeared in JEE 2023 where they are asking you to find the equivalent resistance, and here in JEE 2022 they are asking you to find the current through the given circuit. Now to answer these questions we need to understand Wheatstone's bridge, so let us do that first. So this circuit is called a bridge circuit. Basically if you think about current flowing in like this, the current will branch that way and the current will branch this way. So think of the top branch as like a river. This is another branch of the river. And so between this branch and this branch, X is the bridge connecting these two. That's why it's called the bridge. Okay. Now of course you don't need to know why it's called the bridge, but basically it's good to know that this is flowing like this, right? The current is flowing like that. If you think of that as a river, think of this as a river. This is a bridge connecting the two rivers like that. Okay, so if a current I comes in, you know that the current I has to go out. So that much is clear. What will happen here? Will this be I? No, this will going to branch. This current will branch as I1, I2. And when it goes there, in general, it should branch as something here and something else there, right? Maybe I3 and I4. But some rare cases, what happens is there is no current flowing in here. So if this is I1, I1 will flow through R3. So whatever current comes this way is not branching out here, it is just entirely flowing that way. And since no current is going this way, whatever current comes in here will go like that. So this current in R4 is also I2. So I2 comes in, I2 goes out like that. Now there is no current in this branch X, no current at all. Whatever current I1 is coming like this is going that way, so nothing goes into X. Now will this happen in all cases? No, it only happens when a particular condition is satisfied, and that condition is called Wheatstone's condition. R1 by R2 is equal to R3 by R4. These resistors are proportional. R1 by R2 is equal to R3 by R4. Sometimes people say R1 by R3 is equal to R2 by R4. Well, you can do that also. You can bring R3 down and R2 you can take it up. But I like to think of it this way. This is the bridge. This side of the bridge, that side of the bridge. This side of the bridge, the resistors have to be proportional to that side of the bridge. So R1 by R2 is equal to R3 by R4. X has zero current. So the current in X, Ix is 0. But if the current here is 0, what will be the potential drop? 0. I into R, no, R is 0, right? Current is 0. So 0 into X. Whatever X is, doesn't matter, 0 into X is 0. So if I call this point B and call this point D, VBD is 0. VBD is 0. Okay. Now, please notice, VBD is 0, so there is no current. You can argue it that way. There is no current, so VBD is 0. That also is okay. Now, the main point is, since there is no current here, suppose this was 2 ohms, what will be the potential drop? 0. Suppose I made this 2 ohms into 3 ohms, potential drop is still 0. So I can change this X value, right? From 2 ohms I can make it 3 ohms, I can make it 5 ohms. Actually, the current won't change, the potential drop here will not change, it will be 0. And so whatever current I is coming in will not change. If you change X, if you change R1, if you change R3, etc., I will change, this current will change, I1 will change, I2 will change, everything will change. But if I change X, I make X from 2 to 4 to 7, 17, nothing will change. This current will remain as it is. I1 will be as it is, I2 will be as it is, same I2 will flow here. Nothing will change because this resistance really doesn't matter. So X does not matter. you can replace X by any other resistance. I can keep increasing the value. If you keep on increasing the value, I've made it very, very large. It is like saying this is an infinite resistance, which actually means you can pull out the resistor. So X can be removed. X can be removed. X is removed, obviously there is no current. But that is the final case. Because there is no current, I am removing. Okay, because there is no current, even if I remove X, nothing is going to happen to the rest of the circuit. It doesn't have to only be removed. You can keep on reducing the value of the resistance such that it basically becomes a wire. So X can be replaced by a wire. So X can be removed or replaced by a wire or replaced by 2 ohms, 3 ohms, 7 ohms, 21 ohms. Doesn't matter. The rest of the circuit does not know any of this. The rest of the circuit current will flow exactly as before. Okay. If this condition is satisfied, if Wheatstone's condition is satisfied, R1 by R2 equal to R3 by R4. Okay. X can be removed. Well, if I remove it, it's going to look like this. In which case, the equivalent resistance is easy to find. How? Well, these two are now in series because there's no branch. These two are in series, R1 plus R3. These two are in series, R2 plus R4. And R1 plus R3 and R2 plus R4, they are in parallel. When two resistors are in parallel, you can write R1, R2 by R1 plus R2 as the equivalent resistance. So in this case, I can write the equivalent resistance as R1 plus R3 into R2 plus R4 by R1 plus R3 plus R2 plus R4. I can write it like this. Okay. Well, that is the equivalent resistance, easy to calculate once you have removed X. But I said you can also replace X by a wire. Then you can't say these two are in series, but you can say R1 and R2 are in parallel. So R1, R2 by R1 plus R2, that will be this combination. R3 and R4 are in parallel, R3, R4 by R3 plus R4. And then this and this are in series. And so equivalent resistance is R1, R2 by R1 plus R2 plus R3, R4 by R3 plus R4. Now I told you that these two are exactly the same. Why? Because X doesn't matter. You can remove it, you can put a wire, it doesn't matter. So these two must be the same value. Why am I saying that? Because this current is not changing. So their equivalent resistance must be the same. Because suppose I say there was a battery, right? Battery's EMF divided by the equivalent resistance will be the current. That's not changing. So they must be equal. But wait a minute, they don't look equal. This doesn't look like this at all. They are looking very different. Even if I cross multiply, denominator will have R1 plus R2 into R3 plus R4. You won't get this sum. So something seems wrong. So far I have not even used this Wheatstone's condition. So if I use Wheatstone's condition, I can prove that these two are exactly equal. Let me do that. So suppose I call this K. Okay. R1 by R2 is equal to R3 by R4. Let me call that K. So R1 is K times R2. R3 is K times R4. So everywhere I have R1 and R3, I'll replace it with R2 and R4. Okay, let me do that. R1, R3. R1 is KR2, R3 is KR4. Let me substitute. KR2, KR4, this as it is. KR2, KR4. Okay. Now, here K is common, you can pull it out. You will get K times R2 plus R4, R2 plus R4. Here if I take K out, K times R2 plus R4, 1 times R2 plus R4, K plus 1 times R2 plus R4. See that? I have pulled K out, R2 plus R4, R2 plus R4 as it is, K plus 1, R2 plus R4. Now this R2 plus R4 and this R2 plus R4 I can cancel. So my answer is K by K plus 1 into R2 plus R4, that is when I remove X. Suppose I replace X by a wire, I know this is the answer I am getting, but I have to still substitute R1 is KR2, I will substitute that here, R3 is KR4, I will substitute there, so I will get this. KR2 plus R2 is K plus 1 R2, R2, R2 cancelled, R4, R4 cancelled, K by K plus 1 common. So K by K plus 1 R2, K by K plus 1 R4, so K by K plus 1 into R2 plus R4. Can you see these two are exactly the same? K by K plus 1 R2 plus R4, K by K plus 1 R2 plus R4. So they are equal. So yes, these two are equal. Both of these are equal or equivalent to the original one. So whatever X value is doesn't matter. You can remove X. like this. You can replace it by a wire, you can replace it by 2 ohms, 3 ohms, 7 ohms, whatever ohms, doesn't matter. It will all give you the final same answer. In every case, you will get the same equivalent resistance, same current flow, same I1, I2, and no current through the bridge. No current through the bridge. Here there is no bridge. There also there will be no current through the bridge. So I hope this is clear. Very, very powerful, very useful. Okay, this is called Wheatstone's bridge. Now, of course, whenever we talk about Wheatstone's bridge, I told you, you can imagine this to be a river flowing like this, and this is the bridge. Okay, it's very important. The entry point and exit point is not connected by X. This middle point and this middle point is connected by X. So if it looks like this, everybody is able to recognize that this is Wheatstone's bridge. But sometimes Wheatstone's bridge is also drawn like this. So this is the entry point. The current comes in like this. Okay, and you can see the current flowing like this, branching out, and it will flow like this. And so if you want to connect the bridge, it has to be here. So this is the bridge. This is the bridge X. And that can be removed. That can be removed. So sometimes you will see circuit like this. Of course, they won't mark this in red. So you will have to figure out, oh, this is how the current is flowing. This is how the current is flowing, and this is the bridge. So if you understand that, then you can figure out, oh, this is the bridge. And if this resistance by this resistance equal to this by this, then X can be removed. Only under that condition, only under this condition, you can remove X. Another way in which the bridge circuit sometimes is drawn is like this. Doesn't even look like a bridge, right? But suppose I say the current flows in like this, flows like that, flows in here. Okay, so here also you can see that the current will be flowing like this. So you can see there is one flow here, not from the starting point, okay, not from the ending point, but between these middle points. If you connect a wire or a resistor, okay, like this, this is X. So this is the bridge. And of course, if this side of the bridge, this by this resistance by this resistance is equal to this resistance by this resistance, X can be removed. So you need to keep in mind that the resistors on this side of the bridge, R1 by R2, must be equal to the resistances on that side, R3 by R4 ratio. Then X does not matter. Okay, so this is Wheatstone's condition and this is Wheatstone's bridge. Let us see how to use this to solve the JEE problems. Let us now look at this question that appeared in JEE in 2024. They have given you this circuit and they have asked you to find the value of this unknown resistor X. Assuming that the potential difference between B and D, the potential difference is 0. Basically, if you think about it, this is one branch, this is the other branch, this is going down like this is going up like that, right? So this is one of the rivers, this is the other river, and this would have been the resistance connecting these 2 points, right? That would have been X. We have removed it. Well, you can remove it as long as this resistance by this resistance is equal to this by this, right? So if you think of the bridge there, then you can write R1 by R2 must be R3 by R4, in which case VBD will be 0. The potential difference between B and D will be 0. Okay, but if I want this by this to be equal to this by this, I need to find what this is. Now what is this? 12 and 12, 24, because these two are in series. So these two together, 24. 24 and 24 in parallel, well, that means half. So this whole thing, this whole combination is how much? 12 plus 12, 24, 24 by 2, 12 ohms. This entire thing is 12 ohms. What about this? 0.5, right? 1 and 1 in parallel. Well, if you have two equal resistors in parallel, the equivalent resistance will be half of it. So this will be 0.5 ohms. This is already 0.5 ohms. And then if I want to look at this entire combination, X is in series with this combination. Now what is this? 12 and 12 in parallel will be 6. 12 and 12 in parallel will be 6 ohms, 6 plus X. So this will be 6 plus X. And so this resistance by this resistance must be equal to this resistance by this resistance. So 12 divided by 6 plus X must be equal to 0.5 divided by this resistance is 0.5, which is of course 1. So 12 is equal to 6 plus X, and so X must be equal to 6 ohms. So what is the value of this resistance? 6 ohms. So the answer is option C. So what is the value of X? The unknown resistance, it must be 6 ohms. Let us now look at this question that appeared in JEE in 2023. So they have given you this circuit. If the potential difference between B and D is 0, potential difference between B and D is 0. So obviously we can see that if I have current flowing in like this, flowing in like this, flowing that way and flowing this way, right? You want this potential drop to be 0. No current should flow even if I connect it with a resistance X. So the bridge should be connected between B and D. And when will you be able to say that there is no current flowing through B and D, which is the same as saying potential drop across B to D is 0, if R1 by R2 is equal to R3 by R4. Okay? So this is R1, this is R2, this is R3, and this is R4. What is R1? 6 and 3 in parallel, right? The basic condition, Wheatstone's condition is R1 by R2. If you take a bridge here, on this side of the bridge, the ratio of the resistors must be equal to that side of the bridge, R3 by R4. R1 by R2 must be equal to R3 by R4. Now what is R1? R1 is 3 parallel 6. So that is easy to calculate. R1 is 3 into 6 by 3 plus 6. Always remember two resistors in parallel, R1, R2 by R1 plus R2. That formula is easier to do. So this is 18 by 9, so that is 2 ohms. So R1 is 2 ohms. What about R2? That is very, very easy, series. 1 plus 2, 3. So this is 3 ohms. What about R3? X and 1 in parallel. So X into 1 by X plus 1. X by X plus 1. And this is of course X. So we can write 2 by 3, right? R1 by R2, 2 by 3 must be R3 by R4, X by X plus 1, X by X plus 1 divided by X. X is not 0. Okay. So basically if I cancel the X out, I can write X plus 1 must be 3 by 2, which is 1.5. And so X must be 0.5. X must be 0.5. And so if X is 0.5, we have been told X is 1 by N. 0.5 is 1 by 2. So X is 1 by 2, which is 1 by N. So this means N must be equal to 2. N must be equal to 2. The question was asking you, what is the value of N? The value of N is, it is 2. Let us now look at this question that appeared in the JEE in 2022. Find the current I in the given circuit. Basically, they want us to find this current I. This current is going to flow in like this. Okay, it is going to obviously branch off partly like that, partly like this. Okay, and then it will again come back this way, and then this will be I. So if you look at this, you can say that this is one of those rivers, this is the other of those rivers, and this is the bridge. So this 2 ohm resistance is the bridge X. And if you look at this R1 by R2 on this side of the bridge, R1 by R2 is equal to R3 by R4, right? 4 by 4, 4 by 4, yes, 4 by 4 is equal to 4 by 4. So this condition is satisfied, which means we can get rid of this. I can just remove it. And if I remove it, then this 4 will be in series with that 4. This 4 will be in series with this 4. And so these two together will become how much? 8 ohms. So this together will become 8 ohms. This whole thing will be 8 ohms. Same way this will be 8 ohms. So let me draw the circuit. You have one 8 ohm. And then this will be another 8 ohms. And that will be connected to 40 volt battery. 8 ohm and 8 ohm is how much? Parallel. They are both in parallel. So this is equal to 4 ohms. So this is equal to 4 ohms. So if I now draw the circuit like this, 4 ohms connected to this battery. Usually we draw batteries like this, but this is also okay. This is a different symbol for a battery. So 40 volts, 4 ohms, so that means this current must be 40 divided by 4. So what should be I? 40 divided by the resistance 4, which is 10 amperes. So this current is 10 amperes. So what is the current in the circuit? Answer is A, option A, 10 amperes. Look at this question that appeared in the JEE in 2023. So they have given you this circuit and asked you to find the equivalent resistance between points A and B. Basically between A and B we want to find the equivalent resistance. Now, doesn't look like Wheatstone's bridge, no? Because you also have this extra 16 ohms. So how do I think of this as Wheatstone's bridge? Well, Wheatstone's bridge means you have two rivers. In between the rivers you must have this connecting resistance. So if you think of this as one river, this as the other river, this is in between. Whereas this is not in between. This is between the starting point and ending point. So this is actually flowing like the river. The river, each river is starting from this point and ending there. This is also starting and ending. Starting at A and ending at B. So this clearly is not that X. This on the other hand is X. Right? You can think of this river, and this is connecting between these two. So this is going to be our X. This is going to be our X. Now we can remove X if R1 by R2 on this side. So this is the Wheatstone's bridge. Then what about this? This is extra. This is the extra. This is basically in parallel to that Wheatstone's bridge. 16 ohm is in parallel to this Wheatstone's bridge. So for Wheatstone's bridge, if I can remove X, things get easier, right? Can I remove X? Well, is 4 by 4 equal to 4 by 4? Yes. R1 by R2 is equal to R3 by R4, right? So 4 by 4 is equal to 4 by 4. So we can remove this. And if I remove this, how will it look? It will look like this, right? It will look like one resistance, 4 ohms. This has been removed. Other 4 ohms. And then there is one 4 ohms like this, 4 ohms like that. Okay, so this is 4 ohms, 4 ohms. And then from here till there, there is how much? 16 ohm resistance. This is A, this is B. Now this is 8 ohms, this is 8 ohms, this is 16 ohms. So 8, 8 and 16 in parallel. You can first say 8 and 8 together, right? This is 8 ohms, right? 4 and 4 together series, that is 8, this is 8. So 8 and 8 in parallel will be 4. So you can say 4 ohms and 16 ohms. So next step I can write, this is 4 ohms and this is 16 ohms. And this parallel we can do easily. 4 into 16 by 4 plus 16. So this is going to tell us that RAB or R equivalent is 4 into 16 by 4 plus 16. 4 plus 16 is 20. So if I cancel this out, this is going to give me 5, right? So that is 16 by 5 is 3.2, right? 32 by 10, 3.2. And so the answer is RAB is 3.2 ohms. That is this. Of course, I could have also done it here directly. I could have directly written 1 by RAB is 1 by 8 plus 1 by 8 plus 1 by 16. Because these three are in parallel. So if I take 16 common, 2 plus 2 plus 1, which is 5. So RAB is 16 by 5, which is 3.2. I could have also done it like this. Basically here I have combined these two together because that's easy. 8 and 8 together is 4. So 4 into 16 by 4 plus 16. Or you could have directly said, okay, these three are all in parallel and therefore directly use the parallel formula. For two resistors in parallel, you can use R1, R2 by R1 plus R2. But if you have more resistors in parallel, then you say 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So I hope you have understood how to solve this question. Now we have taken one type of question where you use Wheatstone's bridge to solve a circuit question. I have shown you how you can solve this. But if you actually look at JEE and NEET, there are so many different topics with so many different types of questions. Now I have done all the different topics, all the concepts, all the techniques that you need, and every question type, how to solve. I have done this in great detail in my full physics recorded course that you can get from AahGuru.com. So if you take this course, then you will be able to find that all the concept videos for every chapter is explained in detail. You can also use that to understand how to solve different types of questions. Every question type is covered in this course. Okay, so do take it and try it out. You will find that it's extremely useful for your JEE and NEET. All the best. If you like this video, please hit the subscribe button below. And if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.